smaller than equal to second arrow data, we will call first arrow next is equal to merge of first arrow next comma second. Okay. Return first, else second arrow next is equal to merge second no first comma second arrow next, return second. Yes, should be pretty easy to understand. Yes. So if the first is not there, return second, and second is not there, return first. We compare both of these data. So in both of these data, if first dot data is smaller, which means that the current node should be the first one, we will return the first one. And we will actually call the merge on first arrow next and the second one. So we are calling that. Otherwise, the second will return the second, and second arrow next would be merging of the first and the second arrow next. Yes, sir? Okay. So the one with the arrays is a little bit more. We'll cover it in the sorting and such. But this is a general merge function, right? So and we can actually comma boolean ascending. So your homework part would be to actually see if it is ascending or descending and change this function so that you can actually do it ascending or descending. Now back to the original question. The original question was odd positions should be ascending, even positions should be descending. So what we need to do is, it's 11:40, so I will leave that, but the question should be very simple. You break it in two buckets. One is odd position, one is even position. For odd position, sort it in ascending, even position descending, then merge. So should be easy. Okay.
But how will we merge? Because
okay. So now at some point, this is the odd position one,
yeah,
and this is the even position one. Okay, then we will say for while odd arrow next, like this arrow next exists, then what we do is we actually take another thing and we'll say that this is,
take one from odd,
take one from odd, take one from even.
Take first from odd, first from even. Okay.
Yeah, take the first one from odd and first one from even, and
okay,
continue merging them.
Okay.
It should be pretty easy.
yeah.
Yeah. Okay. So I'm assuming you guys will send me the solution to this one. I haven't coded this one. So I will send you the merge, and you can change it and then send me the solution. Okay. So we have done this one, and then next larger I will do that, and then we will do yes, the random pointer. Okay. Random pointer is yes. Okay. So the question is, and it has been asked a lot of times, and it's an old question, but it's a difficult question to conceptualize and understand. So the question is that there is a linked list, like 1, 2, 3, 4, 5. Okay, which has So it has one pointer which is pointing to the next node. There is another pointer which is actually randomly pointing to anywhere. So let's say the random pointer for 1 is pointing to 3, the 3 is pointing to 5, 5 is pointing to 2, 4 is pointing to 3, and 2 is pointing to 1. This is a random, there's a random pointer which is pointing to everything else. Now the question is, you actually have to copy this entire linked list and return a new linked list. Okay, so we know that it is like a linked list. We have the next, so we can do 1, 2, 3, 4, and 5. The next one is okay, but then after that, how would you do the random one?
Yeah.
That is the difficult part. Okay,
So there are 2 pointers.
there's 2 pointers. So we can write the structure of the node as struct a list node, a list node in data, a list node star next, a list node star arbitrary. Right? So that would be the structure of the list node. Okay. There are 2 solutions to that. I'll do one solution. I'll give you another solution, but we'll see how much time we have. So, yes. Any?
We have to manage the distance between 1 and 3 so that. But I think
Okay.
it was-
That's a n square. That is a yes. We can do that. That's an n square. Yes. We don't have to. We can use hash tables, we can do a lot of other things, but that is like you are using extra space. The thing is like you actually don't have to use the extra space. So what I will do is I'll tell you the solution and we will figure out. Okay. Yes. So now what we do is we actually modify this linked list. Okay. This is the okay. I'll just erase this up. 1, 2, 3, 4, 5. I should have put more space in them. Anyways, okay. And 1 was pointing to 1 was pointing to 3. 1 is pointing to 3, 3 is pointing to 5, 5 is pointing to 2, 2 is pointing to 1, 4 is pointing to 3. Right? That is the case. Now what we do is we actually modify this list and add new list after everything. So after 1 we will add a 1 again. And this will point to the next one. After 2 will point to 2 again. This is pointing to the next one. After 3 we point 3 again. I should have done it in a different color. I will do it in a different color. So we'll do, this does not work. So we have a 1 and 2 and 3 and 4 and 5. Okay. So 1 is pointing to 2, 2 is pointing to 3. Okay. Then what we do is now we actually have to find the arbitrary node, right? Okay. So we did that. Now we start from this list again. We'll say original dash next dash arbitrary is equal to original arrow arbitrary dash next. Okay, so original's next arbitrary node should be pointing to original's arbitrary arrow next. Yeah, so we'll take another color. Original's next arbitrary is pointing to original's arbitrary next. So one starts pointing to, I'll take a different color. One starts pointing to, one starts pointing to 3. Okay, then we skip 1, we go to 2. 2's next arbitrary should point to 2's arbitrary. 2's arbitrary was 2's arbitrary was 1 next. So 2 should point to 1. Now we move to 3. 3's next arbitrary should point to 3's arbitrary arrow. There was a 5 point over here. 3's arbitrary next, which means 3 should point to 5. 4's next arbitrary should point to 4's arbitrary next, so 4 is pointing to 3. Okay, now we will actually, there is a thing. Yes, so now we have pointers to every one of them, right? Now we will actually break. So how will we break? We'll say original arrow next is equal to original arrow next arrow next. So we have to make this back. So original arrow next is equal to original arrow next arrow next. And then we'll say copy arrow next is equal to copy arrow next arrow next. Okay? Yes?
So the initial problem is like there are two pointers and we may need to make 2 lists out of that, right?
So once you do this, you will actually break this. So let's continue again. So original's next is original next arrow next. So 1 is pointing to 2 now, the black 2, and 1 was already pointing to whatever it was, right? And then we go to the next one. So copy is the next one is copy. So the copy is this 1. It is pointing to the other 2. It starts pointing to this, and then we are basically just breaking them. And these were arbitrary pointers were already pointing, so we break that. Yes. Yes, you get this. There is another solution to it, which was like, if you want to take a picture, take a picture. So, and I actually I didn't get enough time to solve this, but I will actually try to solve this right now. So, and you'll see if we have another question. We can do another question.
Excuse me. Sorry, I missed. Like, what are we trying to achieve? Like, what
We are trying to copy this entire list. So the first list we are trying to copy. So the first list was 1, 2, 3, 4, 5, and 1 was pointing to 3, 3 was pointing to 5, 5 was pointing to 2, 4 was pointing to 3, and 2 was pointing to 1. Right? We have to create another one.
Okay.
Is
with this computer?
yes. So
This is the given list. And then,
this is the given list. We have to create an entire copy of this list.
okay. And in linear time.
In linear time. Yes, this will be a linear time. Or O of n. We'll go through it 2 or 3 times, but it will be linear. Do you want me to solve this question? I can try to do that. No. There is one more question. I'll try to solve this question and we'll.
I think that can be homework if everybody agrees.
I don't know, but the thing is, like, I never get any homework back. So that's the thing. Like, nobody solves it. So yes, it is a homework, but I don't know.
Yeah, understanding the logic is important.
Yeah, understanding the logic is there, but the thing is, like, when you sit down to solve it, you'll encounter a lot of problems.
Yeah.
Another thing is, it's not about understanding the logic. Yes, you understand the logic, but like when you go on the board and start writing code, that is when the problems
I
happen.
agree.
You can understand all the logic, but if you have not coded it, I will immediately know that you don't know how to code it. So, anyways, try to solve this. I'll try to solve this. Okay.
Also, writing a code on Visual Studio is lot easier than
Then
writing a code on
doing
Code.
this. So I will do this, and if I do mistakes, it's okay. Like, I have not attempted to solve this. I think I solved this like 5 or 6 years ago when I was trying to, no, not 5 or 6, 2 or 3 years ago. When I was, where did the pen go? There's so many here. Okay. नहीं वो बड़ा वाला जी. Okay. Anyways, I'll just try again. So yes, 2 or 3 years ago when I was trying to switch a job, I solved this, but I did not. So the structure is struct a list node, and it has integer data, and a list node star next, a list node star arbitrary. Okay, and the thing is void. Do we have to return? We can just return a list node star copy list, a list node star node. Okay. So what we will do is for in now a list node star. Do we have to check for the condition? I can just check for the condition. If not node, return none. Okay. Otherwise, we will take a list node star temp is equal to node. Okay. Then we will do while temp is there. We will actually create a new node and insert it between the between this and the next one. So we'll say a list node star add is equal to new a list node. Okay, and add arrow data is equal to, you can tell me what it should be, temp arrow data, because we are trying to copy the temp, right? And then add arrow next should be equal to temp arrow next. Okay, and then temp arrow
Next equal to
next is equal to add. Okay, so this will copy the entire thing into the so it will add new nodes. So at this point the list looks like 1 1 2 2 3 3 4 4 5 5. Yes, so the node looks like this at this point, and 1 is pointing to 3, 3 is pointing to 5, 5 is pointing to 2, and 2 is pointing to 1, and 4 is pointing to 3. Right? At this point, this is what the situation is. Okay. Next, what we need to do? Yes.
One thing over there. So just after temp arrow next is equal to add,
Mm-hmm.
we need to write, because next time when it goes through the loop, it will again keep on creating the 1 1 1 1 after that.
How? Yeah.
Your temp has to move, right?
Yeah, temp has to move. So temp is equal to temp, arrow, next,
Arrow next.
arrow, next. Sorry. Yes. Thank you. So we did that. Now at this point the list is like this. Okay. Now what do we have to do? Can I erase?
Oh
Can I-
no.
Okay.
Instead of tracing that, can we also like do the arbitrary within the same loop instead of going through again?
Sure. That will be the homework.
Okay.
Yeah, I like we can optimize it later on, but I want to get the code first. Okay. So next what we have to do is we have to figure out the arbitrary thing. So while,
Actually, you cannot.
huh?
Cannot?
Because you start from one. Your one is
Third is
pointing.
not there, yes, I know.
Yeah. Okay. So while now we'll make a temp point to the head. Temp is equal to node. So we make the temp go back over here. Now we'll do while temp arrow next. While temp arrow next. So we have to continue going till we reach 5. While temp arrow next exists. I think this should be arrow next. I think this should be the case, but we can check later on. We are going from 1. Okay, so what are we doing? We will say temp arrow. So we have to do this. Original arrow next arrow arbitrary is equal to original arrow arbitrary arrow next, right? So temp arrow next arrow arbitrary is equal to temp arrow arbitrary arrow next. Yes? Yes? And then we will actually make temp is equal to temp arrow next arrow next. Yeah? So this loop will copy arbitrary links. So the first one copied, added nodes in between. My handwriting is super horrible today, but anyways, so I guess you get the idea. Now, can I remove that and do the last part? Yes. Huh? You know that? Okay. Okay. So the next part would be, now I have to think. So now everything is pointing to the next one. So 1 is pointing to 3, 3 is pointing to this 5, this 5 is pointing to this 2, this 2 is pointing to this 1, and this 4 is pointing to this 3. Okay. Now we have to go through this list. So we'll say temp, we'll again make temp is equal to node. We'll again move the temp over here, and then we will do while temp arrow next exists. Then we will actually say temp arrow next. Temp arrow next is equal to temp arrow next arrow next. Okay. If we do that, we might break the link, right?
No,
No?
should be fine.
Then how will we get the second one? Now a temp arrow next is not
So
going to be-
restore the first link as, list as well, right?
Yeah, so we
You have
need
to
a
restore the
next,
first
we
list.
need a next node.
Yes.
So we'll say a list node star next is equal to temp arrow next. Okay. And then next, okay, we need the starting point of that node also, because now we have copied. So we'll say a list node star copy is equal to temp arrow next. This is the node that we will return. So, and then we'll say next arrow next is equal to next arrow next arrow next. Yes, I should have taken a better name, but that's okay. So what I'm doing over here, this was the node. Its next should not point over here, it should point to this one. So that is what I mean. Yes. And this loop will continue, and then we will return the copy. Yes. I think there might be one or two like indexing problem, like I might be going one here or there, but like this video would be there. If you want, what I can do is like I can put it on YouTube. I won't make it public. I'll just make it private. And if you give me your Gmail ID, I will add it to it, and you will get the link. And so that way you can actually see it. I don't want to make it public yet because like I don't want the privacy of you guys to go online. So I will not do that. Okay. Okay, so we did this question. There was another interesting question, which is there's another book, the other book that I showed you. There was a question of finding the median of a circular linked list.